Hello, I wanted to explain about how the the Python is used in Verilog verification or VLSI design. The very first thing is this video is recorded using the OBS Studio, which is an open source screen video capture tool. Okay, then I downloaded the Python from the python.org. So this is the Python idle. Then this requires the MyHDL, which is a Python library that allows hardware designer to write a hardware description in Python and convert them into VHDL or Verilog, which will be synthesizable. Okay. There are other tools are available like a VUnit, which is mainly focused on creating the the test bench framework. Okay. Then what you have to do is you go to uh, command prompt and install uh, the pip here. So the command line is get hyphen pip dot py, which will install the pip. Then you have to install the myhdl. What you have to type is here pip my install myhdl, right? So that is the required library uh, to simulate this one. So with that will have the module the functions like signal, simulation, delay, and always underscore combination. This is used for the combinational uh, logic. We learned about the sequential and combinational logics. Uh, so this is the uh, module, the multiplexer module that contains four ports. Z is the output port, A and B are the input port, and then there is a selection port. Okay, so A and B are the data inputs. So the how this logic works: if selection equal to 1, the Z output takes the A data input. If selection otherwise, it takes the B input. So if selection is 0, it will takes the B input. So this is the small test bench created here, where it uses the random real numbers, or I think random. Let me see, what is this? Yeah, this is a random range function, is a built-in Python function used to generate the random integers. Okay, random integers between given start and stop time, simulation stop time. It is part of the random module. So here you can see this, it is importing the random from random import random range function. So that is used to generate the test bench, where you can see a dot next and b dot next and select dot next is given this random range of 8, a for a and b for the data inputs, random range of 8 is given, 8 random numbers. But for the selection, because it will switches between 0 and 1, only the two randoms numbers are given. Then there is a print statement. It will print the outputs of uh, output, input, and the selection Z, A, B, and selection. It will print. So you are running the simulation. uh, let me see what is the running. Yeah, you are instantiating the multiplexer here in the simulation command, then instantiating the test bench. So you can see the multiplexer is mux underscore 1 is the instant of the mux, which is defined here, right, which is defined here. Similarly, test underscore 1 is instantiated from the test function. It is just like any of your the function is written and you are recalling those functions, right, similar to that one. Okay, so here you are running the simulation sim dot run. So run, let me see, where is the run is given. Yeah, somewhere it's a given. And yes, let me see. Control F, run, where it is written run, how many, how long you are running. Okay, yeah, it is, I think it is determined with the built-in functions. Okay. mm, yeah, yep. So how do you run this one? Go to run, run module, click on the run module. So this will open up the output where the, now you can see the output because you are giving the print statement here Z, A, B and selection. Based on that, it is printing. When the selection pin is 1, you can see A is outputted, right? When selection pin is 0, uh, B is outputted, right? So these are the random 8 numbers generated for A and B. 1, 2, 3, 4, 5, 6, 7, 8 random uh, two integers are generated for A and B, but for the selection you can see between, it will switch between 1 and 0. So this is how, it is simulated and it is showing the output. So this is how the Python is used in Verilog or VLSI design. So this is about how to simulate. Now you can even convert. This is no conversion script in this one. You can convert this one. For example, let me see here. Yeah, this is another design, D flip flop. This will show how to convert uh, uh, this one from the Python. You can see the function, it is called to Verilog. This is the D flip flop where the output Q is the output and D, Q and D are the, sorry, yeah, Q is the output, D and clock are the input. So this is DFF is defined. Then there is a test bench is written. It is simulated here depending upon the time step, and it is simulated up to 2000 time steps. Okay, and this is the last function is the convert function, which will convert from this Python code into uh, Verilog. So, but for some reason this is not working. It is giving some error saying that this particular line number 34 is deprecated. So looks like it is changed from something. I tried to debug and I could not do this one. Otherwise you would get a nice Verilog output, something like let me see. Yeah, I don't have that one. Yeah, that's all about how the Python is used. So obviously we have to give this as a demo when we, before we start the Python class to the students. The if you are giving the basics of Python, so this will give more this will give very good insight of why the Python is used, right? Okay, thank you. Bye. Let me